Hi folks, it's Björn from the Bavarian R2 Builders, and as I'm preparing version 0.3 of the open source software for the Monaco Control System, which is what we call our set of concealable dual remotes, I thought I'd take the opportunity to publish a bit of a video manual and also talk about why we developed these in the first place. So let's start with that. Why did we develop another pair of remotes? Well, first of all, we wanted to have something concealable. We take our droids to conventions, and it's always very nice to have something that you can use to control your droid while your hand is in your pocket or behind your back, so that people don't immediately see who's controlling the droid. Much better for the immersion. There's also the fact that we wanted something powerful with multiple degrees of freedom, and that's mostly due to modern droids like TO or BB-8 or B2 EMO having multiple degrees of freedom in many joints. So for example, DO has a 3 degree of freedom head, and that's very awkward to control with just a joystick. So we knew we wanted something that had an IMU inside. We wanted this also to be usable for many droids and speak many remote control dialects. So while these guys at the moment run XB, there's also an ESP32 in there, so they will at some point speak ESP now, Bluetooth, possibly even Wi-Fi. And last but not least, they are consequently open source on the software side. And there's a couple of reasons for that. The most obvious one is, of course, if you want these to do something that they don't, it's very easy to go into the source code and just implement it yourself. So you can expand them. They're not going to get obsolete, even if we have to pass the torch to some other developer maybe at some point. But I think the most important reason is some of our droids are pretty heavy machinery. R2s, for example, but also B2 EMO is a pretty heavy thing. And things can go wrong if the remotes are buggy. So you definitely want something that can be peer reviewed, that can be checked. If something goes wrong, somebody can go in and fix the bug that's caused it. And you will always know that you'll have something that's safe. Okay, so this just didn't exist on the market, so we had to create our own. Okay, let's take a look at what makes these guys tick. Okay, let's look at the basic features these guys have. So each one, the left and the right remote, has a joystick with a clickable button. It has 4 easily accessible buttons around the periphery, and they're made so that you can reach them with your ring finger, with your middle finger, and with 2 different configurations of your index finger. They both have 3 buttons on top. The right remote directly sends these 3 buttons. On the left remote, the same 3 buttons are used to control the menu system. The right remote has 2 regular potentiometers that you can operate with your thumb. The left remote still sends 2 potentiometer values, but it has an endless encoder instead that you can use to set those and also to control the menu system. There are 2 LEDs here that light up in different colors. The left LED on the left remote and the right LED on the right remote are for the status, so basically the outer, if you see them as a pair, and the inner are for connection information about sending packets. They both have an IMU for 3 axes of rotation, and at the moment 3 axes of acceleration, and soon 3 axes of translation. So in total, this gives us 20 axes with both remotes, with up to 10-bit resolution, plus 13 individual triggers. And while we have one left remote with a display and one right remote without a display, you can of course change the handedness by setting one as primary and the other as secondary. So what you know as mode 1 and mode 2 configuration from your regular RC remote control can of course be done here as well. So let's power the left remote on and see what the screen tells us. First, you're being greeted with a status screen, and as that flips over, you get the main user interface. You see at the top the line that says left remote. That's basically always showing you where you are. On the bottom of the screen, where you see this green flickering box here, that always shows packets that are sent from the left remote, that are received from the right remote, and from the droid to the left remote. So that always gives you a very clear indication on whether the connection is good. If you see red fields in here, that means packets were missed. If you see too much of red fields, that means the connection is not reliable. So you may have some interference or maybe very low on battery power. So that's the top part and the bottom part. The center part shows changing displays. So what you see here right now is an initial schematic view of the remote. So at the top, you see joystick motion. You see button pushes. You see the 2 potentiometers that the left remote can send. And because we don't have 2 potentiometers at this one, these are virtual. So you basically change them with this endless encoder. So that's the top. And if you hold this button here, you see it switches over to the other one. And there's a spirit level down here to show the IMU motion. At the moment, this is configured to output zeros unless you push this button here, and then it recognizes how the remote was oriented. You can see that spirit level basically keeping up with the remote's motion. And we use this, for example, to control DO's head. The 3 buttons here are used to move around on the remote face. We have the previous button, we have the next button, and we have the confirm button. So if we push the next button, we go to the next display, and that shows us the same view, but this time for the right remote. We're not paired yet, so this is not showing any input. And if you push the confirm button, you enter the menu. I hope that's readable. My camera is unfortunately not the very best. So the menu system can be navigated either with these buttons, next and previous, or also with the endless encoder. And you can select individual entries with the confirm button. So what we see here is the pairing menu down there, a menu for settings of the left remote because we haven't paired to anything yet. So let's pair the left and right remotes now. So we go into the pair menu. And say we want to pair with the right remote. And then it takes a while until it finds the right remote. And there you go. By the way, you can change the name that the right remote presents itself as, and also the droid in the code, which is strongly recommended. So if you pair at conventions and there's somebody else with a remote system like this, you don't get confused. Okay, so let's pair with the right remote. And as you can see, we're now seeing the packets from the left remote that are being sent and the packets from the right remote that are being received. And you can also see we have the joystick motion here, we have the potentiometers here, we have all the buttons, so this gets transmitted over to the left remote, and of course we have the same spirit level functionality. Now, one important thing is joystick calibration, and you can do that from the left and right remote menu. This is important because the remote itself understands when the joystick is at center and will send a special signal to the droid, which, for example, DO uses to switch from velocity control mode to position control mode. So let's go into the left remote menu and select Calib joystick. The way this works is you see this red rectangle on the screen. Basically what you try to do is make that the red rectangle as big as possible by just moving the joystick around. When you're done, you just push any of the 3 face buttons and the calibration is stored. So let's do exactly the same thing for the right remote. So we go into the menu, go into the right remote menu, say Calib joystick. You get exactly the same red box. You again try to enlarge it to the maximum, press one of the face buttons, and we're done with the calibration. Okay, let's pair with the droid now. Pairing with the droid works exactly the same as pairing with the right remote. We go into the menu system, select pair, select droid. Takes a while it's looking for the droid. Cue elevator music. There you find generic DO, and we'll select that. And now you'll see at the bottom right, we're getting packets from the droid. The droid also reacts to the remote access. They will be configurable at some point. Right now they are hard-coded. The peripheral buttons trigger sounds. The joystick button switches the drive system on and off. Joystick forward and backward. On the primary remote sets the droid's velocity, joystick sideways turns. If you hold button 4, then you can control the head with the IMU. Very smooth and natural. And joystick motion on the secondary remote, in this case the right one, sets the droid's head backwards and forwards. That's not so elegant right now as it stands in the station. It looks much better on the ground. What if you're left-handed? Well, there's a menu option for that. Just go into the right remote menu, set that as primary, and then you control the drive system with this joystick and the head motion with this joystick. Okay, finally, for some advanced stuff, first of all, the button that controls the level and IMU output, that can be set in the left and right remote menu. I call this incremental rotation because it recognizes how the remote is oriented, and then from there on it tracks the increment. And you can set that to any of the buttons, or you can also disable. In that case, the orientation is always output. And there's a couple of other settings that you can set in the menu for both remotes. You can set the LED level that the remotes use to show their status, from completely off to relatively dim to super bright. There you can set the deadband that the joystick uses to determine whether the joystick is centered. As I said, the remote knows when it's when the joystick is centered and sends a special signal. But sometimes the joystick is a bit noisy and you want to tweak that, so you can do that here. And by the way, if the joystick is centered, the left LED is white, as it is right now. As soon as you move that out of the way, the LED turns green. And then there's a setting for send repeats. And this allows you to send every control packet to the droid, not just once, but several times, which helps sometimes if somebody with a really noisy DSSS Spectrum remote is next to you that's screaming bloody murder at 2.4 gigahertz, and you want to increase range. And last but not least, if you want to install a new firmware and you're not quite sure if it doesn't use a different flash storage format, my suggestion is go to the right remote, say factory reset, and it will do that, and it will turn the LEDs blue, basically waiting for a reboot. And also do the same factory reset for the left remote. And what this does is it completely clears all the flash memory. And basically when you now upload the firmware, you're starting from a clean slate. All right. That was our little video manual for version 0.3 of the software of the Monaco Control System. Hope you enjoyed it. If you have any questions, leave a comment. If you like it, subscribe and hit the like button. Thank you very much for watching. See you next time.